All right, this is the last problem, and we're asked to find the relative extrema on this particular function. And notice I both have the second and first derivative test. I'm going to do the second derivative test first, and then the first derivative test last. And I'm going to probably show you why I'm going to do that here in a bit. So the first thing I'm going to do is I'm going to take. Actually, I'll be doing them at the same time. I'm going to take the first derivative and get 4x to the third minus 3x squared. I'm going to make that equal to 0. And I'm going to factor out an x squared. And I get 4x minus 3. And you can see that x equals 0 is a critical number on f. And x is equal to 3/4 is a critical number on f. So I think what I did is I again made too many columns, so I'm going to cross those off. And I have negative infinity to 0. And I have 0 to 3/4. And I have 3/4 to positive infinity. Alright, and that's in my first derivative. My second derivative I'm going to take here. And oh, by the way, I'm going to write my first derivative, and this is a good habit to have, is write 4x cubed minus 3x squared right above those words. And I'm going to have 12x squared minus 6x. Make that equal to 0. I'm going to factor out a 6x and get 2x minus 1. And again, x equals 0. And x equals 1/2, and so those must mean something. Again, I think I have way too many columns, so I have negative infinity to 0, 0 to 1/2, 1/2 to infinity. Alright, and again I'm going to put this up here, 12x squared minus 6x on top, and I'm going to pick a negative 1, I'm going to pick 1/4, and I'm going to pick 1, and when I pick a negative 1, I'm going to get positive. And so it means f is concave up. That's all I'm going to write down here this time. And when I put 1/4, I'm going to get 12/16 minus 6/4, which is going to be negative, so I'm concave down. And if I put 1 in there, I get 12 minus 6, which is going to be positive, so I'm concave up. So a couple of things here. 0, 0, when I plug 0 into my original part here, 0, 0 is an inflection point. How do I know that? Concavity change. It went from concave up to concave down. Also 1/2, comma, and if I put 1/2 in here, I'm going to have 1/16 minus 1/8, which is a negative 1/8, is also an inflection point. Okay? Alright, I'm coming down here, and I have a negative 1. And if I put a negative 1 in there, it's going to be negative, so that means my function is decreasing. And I'm going to put in 1/2. And when I put 1/2 in here, I'm going to have 4/8, which is 1/2. And if I put 1/2 in here, I get 3/4. So 1/2 minus 3/4 is negative. So that means my function is still decreasing. And when I put 1 in here, I get a positive, which means my function is increasing. So that means 3/4, comma, if I plug 3/4 into here, I get 81 over 256 minus 27 over 81 over 256 minus 27 over 64. I got to multiply that by 4. And I get a negative, that's 108, I get a negative 27 over 256. And that point, since this changed, right, from negative to positive, or from decreasing to increasing, that is a relative minimum. Okay, now here's the other thing I notice. If 3/4, if I would have picked 3/4 as my test point, what I'm doing is test pointing a critical number for my first derivative here. Well, if it's concave up, that 3/4 has to be a relative min because it falls in an interval that's concave up. And if you're a special number in a concave up, you got to be a relative min. Likewise, if I had a critical number in a concave down interval, it would be a relative max. Okay, make sure you remember that. All right, I'm going to graph this. And again, I could make my conclusion statements. I would say that, and I'm not going to write them out, you can. 0, 0 is an inflection point because it changed concavity from concave up to concave down, or change the second derivative changed from positive to negative, or change signs. Also, the second derivative changed signs at 1/2, so 1/2 comma negative 1/8 is an inflection point. 3/4 comma negative 27 over 256 is a relative min because this first derivative changed from negative to positive, or I could say because 3/4 is in an interval that's concave up. All those are reasonable answers. All right, let's see if I can come up with kind of a graph of what this looks like. Okay, I know it's concave up till it gets to 0, and then I have an inflection point, and concavity changes, but it's going to keep decreasing. So here's this. And so now what I'm going to do is go concave, concave down. You can see it's concave down, and then I'm going to concave up again because at 1/2 negative 1/8 it changes, and then it's going to drop a little bit further. It's going to hit that minimum at 3/4 and head right up. Okay, so again I have a change of concavity here, and I have a change of concavity right there, and then I have a relative min, and then I head up, and that's what my graph looks like.